and welcome to another Seed World Giant Views podcast interview. My name is Alex Martin. I am the editor of Seed World, and today I am so happy to host ASTA's Phyto Man, Rick Dunkle, who is the Senior Director of Seed Health and Trade for the American Seed Trade Association. We are here at the ASTA Flower and Vegetable Conference in Orlando, and Rick is here to talk to us about some fun new updates that are happening in the world of phytosanitary and also some important updates.
Well, thank you very much. It's great to be here with you. And just to say, we've had a very fruitful and busy conference so far. There's a lot going on in the phytosanitary world. And I guess I'll start with some of the general areas for updates and then come down to a couple of specific issues that we're dealing with as well. So, on the general side, in the phytosanitary world, as many companies are well aware, there's much more of an emphasis being placed on molecular seed health testing to get your seed certified for export or re-export. And that's starting to cause some problems. That technology is causing us some problems. And the problem is that the technology is those methods are so sensitive, ultra sensitive methods, that they can pick up very, very faint traces of a particular pathogen, or what we believe to be a particular pathogen, if you will. And so we're now addressing the issue of biological relevance. So in the regulatory world, it's black and white. If they detect the presence of a particular pathogen of concern associated with your seed, either your seed won't be certified or it will be rejected port of entry. So how do you relate that data, that information back to phytosanitary risk, if you will? It's called biological relevance. And I can cite many examples of where we believe you can get positive results on a seed health test, but yet you're not measuring living organisms. So we're wrestling with that. We're starting to wrestle with that now in the kind of research we're wanting to support. And so, for example, I'm also involved in our Seed Science Foundation, and we just got a new project up and running, sort of called a bioassay on a chip, right? And so, what this will do is, for example, a traditional bioassay may take 6 or 8 weeks to accomplish, because you have to take plants, grow the plants to a certain stage, inoculate them, and wait for symptoms, and it all has to be in a standardized way. And that technology is not feasible for regulators to use to verify, whether or not a pathogen's living or dead. So we're working with a batch of very high-powered scientists now to adapt some technology that was developed in the health world from some scientists who are conducting research on cancer, to take the technology they've developed and apply it to plants. So if you can picture a little glass chip where we can take plant cells, take the cell walls off, put the protoplasts onto a little chip and keep them alive. And then if a seed health test is positive for a particular seed lot, we could eventually take an extract out, challenge it to that protoplast to see if there's a biological response.
Yeah.
If there's no response, then the inoculum is dead. Okay, and there's many ways it can be dead, of course. But if it causes a biological response, then we have a true positive on a long way to go with this technology, but we believe that it really could be a game changer for us if we can get it developed. So that's one area that we're looking at. This week, we were very fortunate to have a number of people here from USDA, from APHIS in particular, and we had a lot of good dialogue with them about these 2 federal orders on tomato seed, and where are we going with those, and what are some other options possibly to develop to those. We've been talking about a number of other regulatory issues of concern. And then in the bigger world, also talking about the use of what we call the systems approach as an alternative to traditional ways to certify seed, consignment by consignment. So we're entering into pilot stages for some of these efforts. But that as well, in a number of years here, could be a game changer for the industry as well. So a lot of things like that are going on in the world. And another one that was very interesting, we brought in a scientist from the Ohio State University to talk about high throughput sequencing, NGS, these kinds of things in relation to diagnostics. And it's a scary area of science right now. But we were able to bring an academic who's really very good at this technology together with the industry and the regulatory community to say, where are we going with this? What value will it have for diagnostics for phytosanitary purposes in particular? And so very fruitful discussions there. And I think going down the road, not too far down the road, we'll see some research projects being developed from that. So we did a lot of that kind of stuff this week. And then one example issue that we're dealing with now, which is very high concern. Last year, there's a virus in corn called High Plains virus that was recently detected in Chile, last summer. And the country of Chile, the government of Chile, placed those infections down there under what we call official control, regulatory control, and then just recently issued an emergency rule that now requires seed being exported to Chile to be certified free from High Plains virus. Sounds simple, but it's a lot more complicated than that. But we have High Plains virus pretty much throughout corn production areas in the U.S. And by the way, this is just as much a sweet corn issue as it is a field corn issue. It's also a popcorn issue. And also Chile is a country that is heavily used by our industry for seed increasing, counter season production, as well as for the development of new varieties. And it's the development of new varieties that poses some real regulatory challenges because molecular testing of small seed lots is a major issue. We actually our companies collectively send over 1 million small seed lots a year to Chile. And those packets may contain 500 seeds or less, some of them 35 or 40 seeds, and just seeds off of an ear of corn. And how can you effectively test those? So we're looking at other options for this. But so we talked a lot about that. We had a workshop actually just devoted to that subject the day before the conference began. And we developed a strategy on what we got to get done in 2023. And so the first part of that is we're actually sending a delegation to Chile to sit down with our counterpart, Seed Association ONPROS, and the Chilean government, as well as our own APHIS folks, to begin a more extensive exchange of information because we're now, we ASTA have already started we began to fund research for High Plains virus here in the U.S. To develop much more information on just what's going on with High Plains in corn and better management tactics. But how are we can we develop a more effective diagnostic method for it that can be certified through APHIS, these kinds of things. So and the whole idea of seed transmission. We don't know how much of a problem seed transmission is. It occurs at a low rate, but now we have to determine whether or not plants exhibiting those symptoms pose any phytosanitary risk. So there's just a whole litany of issues there, and the only way to go at them is to get some good, solid, credible research done, and continue to work with the Chilean government because they expect to develop a final rule probably within a year. They're doing a risk assessment. We need to know what their issues are so we can direct some of our research that we're funding to address those problems. So it's very, very, just a lot of things going on. They're exciting things. They're very concerning things to our industry. And so we're all working together here to try to come with the most effective solutions that satisfies both the industry as well as the regulatory community.
Yeah, that is a lot to talk about. I
Yeah.
like that you talk about the chips that could potentially make
Yes.
testing and
Hmm.
comparing a sample a little bit easier.
Right.
Now, you mentioned the High Plains virus that's affecting regular corn, sweet corn,
Hmm.
popcorn. Are there any other viruses or seedborne pathogens that companies need to be watching out for in vegetables in
Oh yeah,
particular?
yes. Of course, in the vegetable world, we're already really focused on a number of viruses and viroids, in particular in tomato seeds. The big issues there have been these two federal orders, one for tomato brown rugose fruit virus and the other one for these 6 different what we call POSPI viroids. And what flexibility does APHIS have to make changes to these federal orders? What additional information do we need to develop to help them do that? So that's a major issue in this coming year. And again, there are always the threat of similar viruses coming up. We have cucumber green mottle mosaic virus in California that we're dealing with, and that's a fascinating situation because that's a case where the industry is regulating itself to avoid federal orders and these kinds of things. And so the companies have gotten together to try to protect the one major seed production area for cucurbits, which occurs in Northern California, central Northern California. And how can we protect that area, 10 counties up there, from CGMMV from being brought in and establishing there? So we're talking about an extensive test in, test out program. Seed coming in before it is planted would have to be tested, and also taking a look at the seed coming out of the production system at the end of the year too. So uh, we're working diligently with the state, with the feds, with the research community, all three on that one. So these are very difficult issues to deal with, but the only way we can do it is to work together.
Well, and you brought up tomato brown rugose fruit
Mhm.
virus, which I know I've seen in the headlines quite often, mostly from companies who are developing resistant varieties to it.
Mhm.
Do you think that will help some of those phytosanitary issues if those resistant varieties come to market?
Uh, yes, I do. I mean, there are a number of complicated issues with TOBRFV, and the issue of resistant varieties, I think, is really important because I think in the big picture they will, but we don't have enough information on. And I'll give you an example of does a resistant variety still pose a phytosanitary risk? And what I mean from there is these resistant varieties, in most cases, and even highly tolerant ones, will be asymptomatic. They won't show any symptoms, but they can still contain virus inside of the plant. And so, if, for example, a country says, well, now we'll require you, instead of a field inspection because it can be asymptomatic, we'll want you to test your mother plants. Well, if you run a sensitive molecular test on your mother plants, chances are you're going to still find the virus. Now, does that, and so you won't get it's a black and white thing in the regulatory world. So we still don't know enough yet about does that resistant variety produce seed that is seed, produces the seed where the disease can be seed borne or seed transmitted. We have to connect that dot. That's one of the research components in the High Plains Virus Project for High Plains. But we need to be looking at resistance from that perspective as well. So one solution may lead to another problem in some cases, but we're watching that very closely.
And then I think I just have one last question for you, Rick. Um, you've mentioned some things that you're excited to see in the future, but when it comes down to it, in your perfect phytosanitary world, what would you like to see come about in the future?
Well, obviously, one of the biggest things is this systems approach. I think that's a game changer because what we call consignment by consignment certification. Every single consignment has to have a phytosanitary certificate, be covered by a phytosanitary certificate. And in many cases, there may be a list of 20 or more pests and diseases that have to be specifically addressed on that phytosanitary certificate. And so, for a company, you're trying to move corn seeds, let's say, to 20 different countries, and each country will have different specific requirements for that seed that comes from the same origin, right? Well, under the systems approach, in the big picture, a company would become certified based on its quality management systems to produce that seed. So you would get a phytosanitary certificate that says this seed was produced under a recognized systems approach. And all countries that would import that seed would recognize that one certificate. And so that would simplify things a lot more, and it would promote more innovation as well in the industry because we're all talking about quality seed. And from the perspective of a company, any pest interference reduces seed quality, whether that's a phytosanitary issue or a seed quality issue or whatever it is. And so let's look at the combined effects of these practices and only have to deal with what's left over, what may not be covered under the current practices. And that's what the systems approach is being designed to do. So that's a big one. And then the other one, as I mentioned before, is calibrated seed testing technology. And how can we easily be able to interpret the results of a seed health test relative to phytosanitary risk? Those are two big, huge issues because, as I said before, more and more emphasis is being placed on the use of these molecular methods. And so fewer countries are recognizing field inspections, for example. We're losing a lot of seed treatments, so that kind of thing is going on. So if we can do those two things, I think that would have a huge positive impact on our ability to move seed internationally.
Perfect. Well, thank you so much, Rick. I think
Sure.
that's all the time that we have for today, but thank you to everyone who listened to our lovely podcast. And thank you so much, Rick, for
Sure.
joining us. And stay tuned for some more happenings going on from the Asta Flower and Vegetable Conference. And we'll talk to you all soon. Thank you.
Thank you.